I am Radhakrishna, mathematics teacher. Today we are going to start the new topic parabola. You have studied about a straight line and circle and its properties in your lower classes. Now we are going to learn the chapter parabola. Before that, we need to discuss about conic sections. What are conic sections? Let us see. The sections of a cone, when it is cut by a plane with different positions, are called conic sections. Let us see the different sections of a cone by a plane. This is a right circular cone. Then if a plane intersects this cone like this, then you get a circle. If the plane intersects the right circular cone in this way, then the cross section is an ellipse. And if the plane intersects like this means what? Parallel to this slant height. This can be called as generator or slant height. And when the plane cuts the cone parallel to the slant height, then the cross section is called a parabola. This is parabola. And if the plane cuts the cone with any other angle in any other position, then the section is called hyperbola. Let us discuss in detail about each one. See, you can easily visualize what are the conic sections. See here, this is a double cone. If you take a plane, this pink colored one is plane. If it cuts the cone like this parallel to the slant height, then the cross section is going to be a curve like this. And if the plane cuts the cone, suppose this is the intersection point of the upper cone and lower cone. This is called vertex. Vertex of the two cones, and the line through the vertex perpendicular to the base is called axis of the cone. Now this angle between this generator and the axis is vertex angle or angle of the cone. Okay. Now if this plane makes an angle which is greater than this theta, then the plane cuts the cone in this way, then the intersection will be an ellipse. In the next case, a plane cuts both the cones, upper cone and lower cone, then you will get one cross section here, another cross section here, then both together called hyperbola. Next, again separately, this is a cone, this is a plane cutting the cone parallel to the slant height, then the cross section is a curve like this, it is called parabola. Next is, if the cone is cut by a plane like this, then cross section is a curve like this, it is ellipse. The next is, if the cone is cut by the plane like this, need not be parallel to the axis, you can cut like this, then the cross section will be a curve like this. This is the shape of a hyperbola. But if you take a double cone and if a plane cuts both the cones like this, then you are going to get one cross section like this and another cross section like this, and both together called one hyperbola. They are called branches of one hyperbola, two branches of one hyperbola. Hyperbola will have two branches, whereas parabola has only one branch, because if you draw any plane parallel to the slant height, it cannot cut the other cone, it can cut only one cone. So, you are going to get only one branch of a parabola. Next is, if you cut the cone parallel to the base or perpendicular to the axis, then the cross section is a circle. You can assume that the circle is a special case of an ellipse. Okay. So, circle is also a conic section, but usually we do not include it in conics. Only parabola, ellipse and hyperbola are called conic sections, but if you talk strictly, circle is also a conic section because it is obtained from the cone. Now, if you cut the cones by a plane through the vertex, through the common vertex of the upper cone and lower cone, then the cross section is going to be a pair of lines. So, pair of lines is also a conic section. You can assume that it is a degenerate case of a conic section, okay, and it is a degenerate case of a hyperbola. That is why properties of pair of lines and properties of hyperbola will be close to each other. Okay. Now, let us discuss the definition of the conic. First point, here circle, parabola, ellipse, hyperbola are called conic sections. What is the link between these curves? All the points on these curves move in such a way that every point on a conic moves such that its distances from a fixed point and a fixed straight line are in a constant ratio. This is the general property of all these conics. Now, if you take any one of the three conics, every point on the curve moves such that its distance from some fixed point and distance from some fixed line, this distance and this perpendicular distance will be in a constant ratio. If S is the fixed point and suppose L is the fixed line and PM is the perpendicular from P on this fixed line, then SP by PM will be a constant. Okay. These distances are in a constant ratio. This is the common link of all the conics. Now, let us define the conic like this. The locus or the path of a point P which moves such that its distance from a fixed point is a constant times, that constant is denoted by E, a constant E times its distance from a fixed line is called a conic or conic section. That is the common link of all the conics. Now, this distance SP by distance from the line is a constant E. Okay. Now, that fixed point is called focus of the conic. This fixed point is called focus, and this fixed line is called directrix of the conic. This line is called directrix of the conic, and the fixed ratio is called eccentricity of the conic. This is the terminology used in conics. Now, the same diagram, this is a conic, every point P moves such that SP by PM is a constant E which is called eccentricity. S is focus and the fixed line is directrix. Now, if you draw a line through the focus perpendicular to the directrix, that line is called axis of the conic. Okay. Next, the point of intersection of the axis and the conic is called vertex. Usually it is denoted by capital A. So, this is vertex of the conic. Okay. And every conic will be symmetric about its axis. See, the above one and below one will be mirror images to each other about the axis. Next, if you draw a chord perpendicular to the axis like this, it is usually called double ordinate of the conic. This is called double ordinate. If the double ordinate passes through the focus, it is called latus rectum. Latus rectum of the conic. Next, if you join any point P on the conic and the focus, then SP is called focal distance or focal radius. This is called focal radius. You need to remember all this terminology. In further classes, we will directly use all these terms in theory and problems. Okay. Next, if the eccentricity of the conic is equal to 1, the conic is called a parabola. If the eccentricity is less than 1, then the conic is called ellipse. If the eccentricity is greater than 1, the conic is called hyperbola. So, here what is the eccentricity? SP by PM. So, in case of parabola, what happens if A is equal to 1? SP is equal to PM. That means P will be equidistant from focus and directrix. This distance will be equal to this distance in case of parabola. In ellipse, E is less than 1. So, SP is less than PM. So, point will move closer to the focus than the directrix. This length will be less than this length. And if E is greater than 1, then SP will be greater than PM. So, P will be closer to the directrix than the focus. So, with the same focus and same directrix, if you draw the three different conics, for parabola, the point will be equidistant from focus and directrix. So, if you take midpoint of this, the curve, the parabola passes through the midpoint, and if you join all points which are equidistant from this and this, if you take this point, this distance will be equal to this distance. Then the curve will be like this. This is the shape of the parabola. Now, if you draw an ellipse with the same focus and directrix, the point will be moved closer to the focus than the directrix. So, this is the shape of the ellipse. For hyperbola, points will be closer to the directrix than the focus. Then you will get this shape. So, this is the difference between the shapes of ellipse, parabola and hyperbola. Okay. Now, equation of a conic. Let us consider focus as some h comma k and directrix as Lx plus My plus n is equal to 0. Now, how to find the equation of the conic section? And eccentricity should be given, otherwise you cannot find the equation of the conic. Take a point P x comma y on the conic. Suppose this is the conic, you want to find its equation. Focus is given, directrix is given, okay. Then eccentricity is given. What is the condition? Sp is equal to, if this is Pm, Sp by Pm is equal to E. Then Sp is equal to E into Pm. Squaring on both sides, we get Sp square is equal to E square into Pm square. Sp square is what? Distance formula. X minus h whole square plus y minus k whole square is equal to E square into Pm square. What is Pm square? Perpendicular distance from x comma y to this line will be Lx plus My plus n by root L square plus m square whole square, Pm square. Now, if you simplify it completely, what kind of equation will you get? You will get the general equation of the conic in the form of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. See, this is a second degree equation in x and y. There will be x square term, y square term, xy term, and there will be first degree terms and constant also in the equation. So, after the complete simplification, you will get it in the form of this equation. So, this is the general equation of a conic. Now, how to know what is the name of the curve represented by this equation? There are conditions. The equation S is equal to 0 represents a pair of lines. If delta is equal to ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. I think you have studied this in a previous class. The condition for this equation to represent a pair of lines is this, you have to remember. Now, we have already completed circle. So, what are the conditions that this equation represents a circle? Coefficient of x square should be equal to coefficient of y square and coefficient of xy should be 0. This is a circle if a is equal to b and h is equal to 0, and it will be a parabola if delta is not equal to 0 and h square is equal to ab. Already we have seen the general equation. If the focus is h comma k and eccentricity is E, this is the equation of the conic. Now, if you compare this and this and taking E is equal to 1, we will get this condition h square is equal to ab. Similarly, if you take E less than 1, then E square will be less than 1. Then comparing them, we get the condition delta not equal to 0 and h square is less than ab. If it is hyperbola, E is greater than 1, then we get the condition delta not equal to 0 and h square is greater than ab. No need to remember the proof, how to prove that h square is less than ab, h square is greater than ab. So, do not worry about it, just remember it, that is enough. Now, we start parabola. First we have introduced conic sections. Parabola is one of the conic sections. Now, we separately define a parabola. What is the definition of parabola? Since eccentricity is equal to 1, the locus of a point which moves equidistant from a fixed point, which is called focus, and a fixed line which is called directrix is a parabola. If you take a fixed point and a fixed line, take all points which are equidistant from both, like this. This distance must be equal to this distance and join them. You are going to get a curve which is called parabola, and this fixed point is focus, fixed line is directrix, and as we have already discussed, if you draw a line through the focus perpendicular to the directrix, it is called axis, and this point is called vertex. Okay. Next, if you join any point and the focus, that is called focal radius. If you draw a chord perpendicular to the axis, it is called latus rectum. Okay. This is the diagram, this is focus, and this PQ is perpendicular to the axis, it is called latus rectum, and this point is called vertex. Okay. In addition to this, if you draw a tangent to the parabola at vertex, it comes like this. It is called tangent at vertex, and this tangent at vertex also has got some importance in this chapter. Okay. Next, and Z is foot of the perpendicular from the focus on the directrix. Now, let us observe how we get a parabola. See, this is an animation, you can easily visualize the shape of the parabola. This is focus, this is directrix. See, the point is moving equidistant from focus and directrix. So, if you join all points covered by this position, you can observe the shape of the parabola. Okay. And if it is a parabola, if it is an ellipse, point moves closer to the focus than the directrix, then those points will be moving like this. Okay. And if you continue, then you are going to get a closed curve which is ellipse, and if the point is closer to the directrix than the focus, then you are going to get the path of the moving point like this. This is hyperbola. Okay. Now, let us solve few problems on the theory discussed so far. Before solving problems, let us once again discuss few more points about the parabola. In the parabola, see, A is a point on the parabola. A is a point on the parabola, vertex is a point on the parabola. So, it should be equidistant from the focus and directrix. That means AS is equal to AZ. Okay. Next, this is length of the this is the latus rectum PQ, and P is a point on the parabola. So, this SP will be equal to PM and PM will be equal to ZS. Okay. Therefore, SP will be equal to ZS and PQ will be 2SP, is it not? Therefore, if the length of the latus rectum is PQ, then this is half the latus rectum, we call it as semi latus rectum, that is equal to distance between the focus and directrix. So, the important point is the distance between the focus and directrix is equal to half of the latus rectum or semi latus rectum. Okay. Now, let us start the problems. Find the equation of the parabola having focus at 1, 2 and directrix 2x plus y plus 3 is equal to 0. Focus is given, directrix is given. Then what is the eccentricity? It is a parabola. So, eccentricity is 1. Every point moves equidistant from this point and that line. Okay. The line is 2x plus y plus 3 is equal to 0 and the fixed point or focus is 1, 2. If you take any point P x, y on the parabola, this is the parabola. If you take any point P on the parabola, then the distance from the focus S will be equal to perpendicular distance from the directrix. So, we have to take SP is equal to PM. Then SP square is equal to PM square. What is SP square? X minus 1 whole square plus y minus 2 whole square is equal to PM square. What is the perpendicular distance from x, y to this line? It is 2x plus y plus 3 by root over 2 square plus 1 square, that is root 5 whole square. This is the equation of the parabola or locus of Px, y. Let us simplify it. This is x square minus 2x plus 1 plus y square minus 4y plus 4 is equal to, expand this, 4x square plus y square plus 9 plus 4xy plus 12x plus 6y divided by 5. Cross multiply by 5, we will get 5x square plus 5y square, this one. Next 5 into minus 2, minus 10x. Next 5 into minus 4y, minus 20y. And here 1 plus 4 is 5, 5 into 5 is 25 is equal to 4x square plus y square plus 9 plus 4xy plus 12x plus 6y. Now, we get 5x square minus 4x square, x square, then we should write xy term. What is the xy term? 4xy. Taking it this side, you will get minus 4xy. Next 5y square minus y square plus 4y square. Now, first degree terms, minus 10x here, minus 12x comes this side, it becomes minus 12x. So, minus 22x. Next coefficient of y, minus 20y and minus 6y, minus 26y. Next constant term, 25 minus 9, it is plus 16. So, this is the equation of the parabola. Now, you can notice that h square is equal to AB is satisfied. We got it, we got the equation of the parabola in the general form. What are the conditions for parabola? H square should be equal to AB and delta not equal to 0. What is h square? This is 2hy, 2hxy, h is minus 2. H square is 4. What is AB? That is 4. So, h square is equal to AB is satisfied. You can also check delta. it is not equal to 0. Next, if minus 6 comma minus 6 and minus 2 comma 2 are the focus and vertex of a parabola, find the equation of the parabola. Let us take a parabola like this. This is vertex, this is focus. Focus and vertex are given. Focus is minus 6 comma minus 6, vertex is minus 2 comma 2. How to find the equation of the parabola? For finding the equation of the parabola, we need focus. Focus is given, and along with focus, what else we need? Equation of the directrix. How will be the directrix here? We already discussed that A will be equidistant from the focus and directrix. So, directrix will be somewhere here. This is Z. Okay. This is directrix. A will be the midpoint of ZS. Sorry, A will be the midpoint of ZS. Now, directrix will be perpendicular to the axis, and focus and vertex both lie on the axis. So, let us start with slope of the axis. Slope of the axis of the parabola. It is the slope of the line joining these two. How much? Minus 6 minus 2 minus 8 by minus 6 plus 2. It is minus 4. It is 2. Slope of the axis is 2. Therefore, slope of the directrix will be minus 1 by 2 because it is perpendicular to the axis. Therefore, slope of the directrix will be minus 1 by 2 because it is perpendicular to the axis. Okay. If the slope of a line is m, slope of a perpendicular line is minus 1 by m. Next, for finding the equation of the directrix, you need the point Z. Since A is the midpoint of ZS, A is equal to Z plus S by 2, midpoint formula. Point A is equal to point Z plus point S by 2. Then cross multiplying, we get Z plus S is equal to 2A. We want Z. Z is equal to 2A minus S. What is 2A? 2 times the point minus 2 comma 2 minus 4 comma 4. 2A means multiply the coordinates by 2 minus 4 comma 4 minus S. S is minus 6 comma minus 6. Then what will you get? Minus 4 plus 6 is 2, 4 plus 6 10. Okay. Now, after getting Z, directrix is the line passing through Z and having slope minus 1 by 2. So, what is the equation of the directrix? Equation of the directrix is y minus 10 is equal to slope minus 1 by 2 into x minus 2, simplified. After getting the equation of the directrix, now finding the equation of the parabola is same as the previous question. You try and finish it. Okay. Next question, if the extremities of the lattice rectum of a parabola are 0, 1 and minus 2, 3, find the vertex and directrix. Suppose this is the parabola, this is the axis and focus is here, vertex is here. So, directrix will be like this. Now, extremities of the lattice rectum are given. So, draw the lattice rectum, let P and Q be the extremities of the lattice rectum. It is 0, 1, this is minus 2, 3. We have to find its vertex and directrix. If PQ is lattice rectum, then S will be the midpoint of the lattice rectum. Lattice rectum is a chord through the focus perpendicular to the axis of the parabola. So, first immediately we will find focus. Focus is the midpoint of the lattice rectum. So, midpoint formula minus 2 plus 0 by 2 minus 1, 3 plus 1 by 2 that is 2. Focus is minus 1, 2 denoted by S. And we have already discussed one property. What is that property? Distance between the focus and directrix, that is ZS, will be equal to half of the lattice rectum, half of the length of the lattice rectum. What is the length of the lattice rectum? Distance between the given points, PQ is equal to how much? Root over 0 plus 2 whole square 4 plus 1 minus 3 whole square 4. Root 8 is 2 root 2. If the total length is 2 root 2, then ZS will be half of the lattice rectum, root 2. How to find the coordinates of Z? What is the slope of PQ? PQ will be perpendicular to the axis or PQ is parallel to the directrix. So, find the slope of PQ first. Three minus 1, 2 by minus 2. Slope of the line PQ or slope of the lattice rectum PQ is minus 1. Then what is the slope of the axis? It will be plus 1. Okay. Now, you take the slope of the axis as tan theta. Then, with the help of the point S, the coordinates of S and tan theta, we can write the equation of the axis parametrically. The parametric equations of the axis are, how to write? X is equal to h plus r cos theta, y is equal to k plus r sin theta. X is equal to h plus r cos theta. What is h? X coordinate of this point focus, that is minus 1 plus r into cos theta. If tan theta is minus 1, then theta is pi by 4. then what is the cos theta? Cos pi by 4, 1 by root 2. So, you will get r into 1 by root 2 comma y is equal to k plus r sin theta. K is 2 plus r sin theta, theta is pi by 4. So, we get r by root 2. What is r in the parametric equations? Distance of any point on the line from the given point S. Here -1 and 2 are coordinates of S. If you put r is equal to 1, you will get point at a distance of 1 unit. If you take r is equal to 2, you will get point at a distance of 2 units. But at a distance of 2 units, you will get one point this side, another point that side. So, we have to take r is equal to plus 2 as well as minus 2, so that we get both the points, this side and that side. Distance of z from S is how much? Zs, root 2. So, if you take r is equal to root 2, you will get a point at a distance root 2. But there will be 2 points at a distance root 2, one this side, another this side. So, let us find both, then identify which is z. Okay. Now, taking r is equal to plus r minus root 2. Taking r is equal to plus r minus root 2. Take plus root 2, taking plus root 2, we will get 0, comma 3. Taking r is equal to minus root 2, we get minus 2, comma 1. Any one of them can be z. How to know which is the correct point z? Here what is both are possible here, that z is also possible, because with the same latus rectum we can draw another parabola like this. This is also satisfying all the conditions. So, z may be this or this, but focus is same. So, this is z. So, you are going to get two equations and two parabolas exist. So, if you want vertex, taking one of them as z, find the midpoint of z and S. Okay. Vertex is equal to, if you take this as z, midpoint of Zs, how much? Minus 1 by 2, 2 plus 3 by 2, 5 by 2, or if that is z, we get minus 3 by 2 comma 3 by 2. Okay, we got vertex as well as equation of the directrix also you want. For getting equation of the directrix, what will you do? Take slope same as slope of PQ. Slope of PQ is minus 1. Taking slope PQ and point Z, this one or that one, you can find the equation of the line. You will get two directrices, one for this parabola and one for this parabola. The other directrix will be like this. Okay, it is only finding equation of a line using the point and slope. So, I hope you can finish it. Now, to understand and study the properties of a parabola, with the help of general equation, you cannot observe anything. Okay. So, what we do is, in order to understand the properties or study the properties of a parabola, we derive a simple equation of a parabola, that is called standard form of a parabola. There are different standard forms. Let us discuss one by one. y square is equal to 4ax is called standard form of a parabola. In this standard form, we take x axis as axis of the parabola. This is x axis, and we take origin as vertex and focus at a distance small a from the origin, from the vertex. So, coordinates of the focus will be a comma 0 on the positive x axis. Now, what will be the directrix? This is vertex, usually it is denoted by a, but here in this case it is origin. A is equidistant from the focus and directrix. So, distance of A from S is small a. So, distance of directrix will be same small a, but directrix will be perpendicular to the axis, means parallel to y axis. So, directrix will be parallel to y axis and this distance is a. So, what is the equation of this directrix? It is on left side of y axis, no? So, it will be x is equal to minus a. So, we are assuming that x axis is axis of the parabola, origin is vertex, focus is a comma 0 on the positive x axis, directrix comes as x is equal to minus a, or you can write this equation as x plus a is equal to 0. Now, how to find the equation of the parabola? If you take a point P, x comma y on the parabola, SP should be equal to PM. SP should be equal to PM. So, SP square is equal to PM square. What is SP square? Distance formula, x minus a whole square plus y minus 0 whole square is equal to PM square. For PM square, you no need to apply distance for perpendicular distance formula. If this is x comma y, this length is x, distance of P from the y axis is x, and this is what a. So, distance PM is x plus a. So, this is equal to x plus a whole square. Then simplify it, y square is equal to x plus a whole square minus x minus a whole square is 4ax. So, that is how we get this equation, y square is equal to 4ax. This is standard form of the parabola. Okay. Now, there is a geometrical property of the parabola which you can understand with the help of this equation. What is the geometrical property? In this equation, you need to understand this y as distance of P from x axis. X axis means axis of the parabola. I will use another color. This PM is nothing but y. So, I will write y as PM square. Y square as PM square is equal to 4a into x. X is nothing but distance of P from y axis. So, 4a into Pn This is the geometrical property of a parabola. And you can understand the same property in a different way. Pm square by Pn is 4a. It is a constant for any position of P on the parabola. That means for any point P, square of the distance from the axis square, this whole square is divided by distance from tangent at vertex is always constant and equal to length of the lattice rectum. Okay. So, using this property we can solve many problems. Let us see later. Now, another standard form. First, let us list out all the characteristics of this parabola y square is equal to 4ax. The characteristics are: its vertex is origin, focus is a comma 0, equation of the axis, axis is x axis, its equation is y is equal to 0, tangent at vertex is y axis, equation of the tangent at vertex is x is equal to 0, that is equation of the y axis. Directrix is x plus a is equal to 0, equation of the directrix. We have already discussed about it. On left of y axis we will have a line parallel to y axis at a distance a, small a. Its equation is x is equal to minus a or x plus a is equal to 0. Length of the lattice rectum of this parabola. This is very important point about this parabola. We have assumed that this length is a, because vertex is origin, this is a comma 0, so this is a. So, this is also a, because O is equidistant from Z and S. So, this length is 2a, and we already discussed that this length is half the lattice rectum. If this is the lattice rectum, half of the lattice rectum is 2a. So, what is the length of the lattice rectum? It is 4a. So, this upper part will be 2a, lower part will be 2a, length of the lattice rectum of the parabola is 4a. This is one of the most important characteristic of this parabola. Next, focal distance of a point P x1 y1. Let us take a point P x1 y1 anywhere. You want focal distance. Focal distance means SP. That SP is called focal distance. SP is equal to, it is equidistant from the focus and directrix now. So, SP is equal to, I will write PM. Instead of SP, instead of applying distance formula, I am going to write SP as PM. What is PM? We know that this is A, and what is this? X1. So, what is PM? X1 plus A with mod. So, focal distance of the point P x1 y1 is mod x1 plus A, it is a formula. Now, let us discuss another standard form. If you take focus on negative x axis at a distance a, if you take focus at a distance a on the negative x axis, coordinates of the focus will be minus a comma 0. Then the directrix will come on the opposite side. You will get directrix like this, and parabola will come like this. That is second standard form. You can get it, you can get all these characteristics by just replacing a by minus a. In all these parabolas, we are assuming that a is a positive number. Okay. So, if you replace a by minus a, you are going to get all formulae corresponding to this parabola. Its focus is here, yes, it is minus a comma 0, this is vertex origin and this is z. This is positive x axis, this is y axis. Now, let us see the characteristics of this parabola. First point, its vertex is origin, focus is minus a comma 0, axis is x axis only. But one important point is, in the case of this parabola, axis is x axis. Here this is positive x axis. So, we can particularly say that the axis of the parabola is positive x axis. The parabola is towards the positive x axis. Though the straight line has no direction, we say that the axis of the parabola is positive x axis. Here axis is negative x axis. Next, tangent at vertex. At this point, if we draw tangent, what is it? Y axis. So, tangent at vertex is y axis, equation is x is equal to 0, same as that parabola. Directrix is x minus a is equal to 0. This is on right side of y axis at a distance a units. What is the equation? X is equal to a or x minus a is equal to 0. Length of the lattice sectum is, we have just turned this towards left, same size, we have not changed anything. So, obviously length of the lattice sectum will become 4a, it remains same. Focal distance of a point x1 comma y1, if you take a point p x1 y1, this focal distance will be equal to mod x1 minus a. We have to replace a by minus a. Next, there is another standard form. This time I am going to take focus on y axis, positive y axis, 0 comma a, origin is the vertex. Then I will get the parabola like this, towards positive y axis. Then where will be the directrix? The other side. Vertex must be equidistant from the focus and directrix, no? So, directrix comes this side, below the x axis. This distance is a, so this distance is also a. So, what is the equation of the directrix? Y is equal to minus a or y plus a is equal to 0. Then find the equation of the parabola as usual by taking point px comma y, take sp is equal to pm, then sp square is equal to pm square, and simplify, you are going to get the equation x square is equal to 4ay. Just to have changed x axis and y axis, interchanged x axis and y axis. Then the previous parabola, this diagram, if you turn it like this, it becomes this diagram. Now, what are the characteristics of this parabola? First point, vertex. Vertex is what? Origin. Focus 0 comma a, we have assumed. Axis of the parabola, this is axis, what is it? Y axis. In particular, it is positive y axis. equation of the axis is x is equal to 0. Tangent at vertex, vertex is origin, clearly the tangent at vertex is what? X axis. Equation is y is equal to 0. Next, equation of the directrix. Directrix is below the x axis, its equation is y is equal to minus a or y plus a is equal to 0. Length of the lattice rectum, we have not changed the size of the parabola, we just interchanged x axis and y axis. So, length of the lattice rectum means here this will be the lattice rectum, chord perpendicular to the axis passing through the focus. Its length remains as it is 4a. Next, focal distance of a point x1, y1. In the previous formula, what did we get? For y square is equal to 4ax. Focal distance was mod x1 plus a. Here, it will be mod y1 plus a. X becomes y. Now, if you change this parabola like this, means direction of the axis becomes y, negative y axis. Okay. We have just flipped it like this. Then what will be the new characteristics? Let us see. This is the parabola. This is origin. Okay. What will be the equation of the directrix? It will be above the x axis. Y is equal to a. The equation of the parabola will be x square is equal to minus 4ay. So, x square is equal to plus 4ay is upward parabola. X square is equal to minus 4ay is downward parabola. Let us see the characteristics. Point number 1, its vertex is at origin. In all these forms, in all these standard forms, vertex is origin. Focus, where is the focus? It is on the negative y axis, 0 comma minus a. Replacing a by minus a in the previous standard form, we get this. Axis is the x axis, y axis. This is axis. In particular, it is negative y axis. Next, tangent at vertex is the x axis. At origin, if you draw a tangent, it is x axis. Equation of the tangent at vertex is y is equal to 0. Directrix is y minus a is equal to 0. We have already discussed. This is y minus a is equal to 0. Length of the lattice rectum remains same. This one length, this one is of length 4a. Focal distance. In the previous result, replace a by minus a, we get mod y1 plus a, mod y1 minus a. Now, let us put all these results in the form of a table. This is the shape, its equation is y square is equal to 4x, and these are the characteristics. This is y square is equal to minus 4ax and its characteristics. This is x square is equal to 4ay and its characteristics. Next is x square is equal to minus 4ay and its characteristics. It is very easy to remember. If you can remember this table, you can directly fill the remaining table. How? Just you have turned it like this. That means plus x becomes minus x. Is it not? So, replacing x by minus x, you will get this, or replace a by minus a, because focus here focus has coordinates a comma 0, here minus a comma 0. So, replacing a by minus a everywhere, you will get the second column. Here you are interchanging x and y axis. So, interchanging x and y and interchanging the x coordinate and y coordinate, this column becomes this column. Again, here replacing a by minus a in the third column, you will get the fourth column. Okay? So, you can easily remember all these results. The main standard form is this: in solving problems or in proving any result or in understanding any property of the parabola, we use y square is equal to 4ax. Okay. Now, we can write y square is equal to 4ax parametrically. How? Since RHS is perfect square, LHS is a perfect square, let us write RHS also as a perfect square. 4 is 2 square, but A is there, so we should take another A in the x coordinate. So, in x, let us take A, but A is a constant, x is a variable. So, along with A we take some square of a parameter, square of a variable. So, if you assume that x is 80 square, then you will get 4a square t square. If y square is 4a square t square, then y will be 280. So, we get the point 80 square 280. For any value of t, the point lies on this parabola. So, these two equations are called parametric equations of this parabola. So, if you want to take a point on this parabola, you can directly take 80 square 280 in proving any result. Actually, we do not use parametric equations of the remaining, but if you want, you can take parametric equations of this by replacing a by minus a. And if you want parametric equations of x square is equal to 4ay, you just interchange the coordinates. Any point on this parabola will be in the form of 280 comma 80 square. So, x is equal to 280, y is equal to 80 square will be the parametric equations of this parabola. Okay. So, but usually we use parametric equations of this parabola only. So, this is about the theory about conic sections, parabola, and the standard forms of the parabola, and we discussed a few important points about parabola. So, tomorrow in the next class we are going to meet and discuss more theory, and we will solve more problems on parabola. Okay, thanks for watching.